Leet code question 78, subsets. To be able to solve this problem, we need to incorporate the backtracking algorithm. And backtracking, it's commonly used in problems where there are multiple decisions to make, and you want to explore all possible combinations of these decisions. Given an integer array nums of unique elements, return all possible subsets, the power set, and a subset is defined as a subset of an array is a selection of elements, possibly none, of the array. The solution must not contain duplicate subsets, and you can return the solution in any order. So if we have a look at this example here, example 1, we have an array of the numbers 1, 2, and 3. Now we could not include any of the numbers, and that would be a valid subset. So here we have an empty array, and we could include all of the numbers. So we have the numbers 1, 2, 3 in an array, but we could also have any of these sort of combinations of either picking a number or not picking a number. So here we see we've got 1, here we've got 2, 1 and 2, 3, 1 and 3, 2 and 3, and importantly we don't have any duplicates, so we don't have 3 and 2, for example. So this is an interesting question, and it turns out the time complexity of this is 2 to the power of n, which is quite big, but it's the only way you can get all of the possible subsets. And the reason it's 2 to the power of n is you have a choice at each element. So you can either include the element in the current subset or exclude it. So let's say we're on the number 1 here. If we exclude it, we get an empty array. If we include it, we get 1. But then with the excluded subarray, we can make the decision to include 2, or for the 1, we can include 2 here. And as you can see, that's sort of, you have a decision at each step of the way to make. So, you know, it's going to be 2 to the power of n, because if you think about these first 4 numbers here, for example, these first 4 combinations here, we consider 1, and then 2, and then we have these combinations here, so that would be 2 to the power of 3, 2 to the power of 2, and then if we go to 3 numbers, that would be 2 to the power of 3, which we got here, so 2 to the power of 3 is 8, and then we can see all those 8 numbers there, so 1, 2, 3, 4, 5, 6, 7, 8, so 8 combinations. Let's start off by defining a variable, subsets. This is what we're going to give back, and this is just going to be an array of numbers, arrays, and we'll initialize that to an empty array. And we also want to keep track of the current subset. So let's go ahead and get the current subset here, and that's just going to be equal to a singular number array. And we'll also initialize that equal to an empty array here. And then at the end here, we're going to want to return the subsets. So let's go ahead and return the subsets. And that'll be the final solution, but we just need to put in a couple of intermediate steps here. So basically, the way this is going to work is we need to be able to backtrack. And backtracking is the key to solving this question. So essentially what we want to do is we want to work out the current subset, and if it's, you know, we want to push that to the subsets if it isn't already a subset. And then we basically want to recursively call a backtrack function which takes into consideration the particular element that you're on, and it's going to essentially do backtracking, which means it's going to get all of the different combinations for all of the different numbers that you're on. So let's just go ahead and just write a function here. So I'm just going to do an arrow function here, and I'm going to call backtrack, and I'm doing a function within this function here, just because we want to make use of these variables here, these sort of global variables, let's say, or within the scope of the subsets. Of course, you could probably do this in a different way if you like, but I think having a closure here for that is perfectly fine. So let's just create a function. And essentially what we want to do is we want to call this backtrack function starting at the 0th element. And we sort of want that to just go through all the different combinations for each of the indexes here. So it's going to be a recursive function. So the first thing I want to do here is I want to just say if the index we're on, if that's equal to the length of the array, then what we want to do is we want to take the subsets and then we want to push the current subset that we're on. So we're going to also make some adjustments to this as well. So in the first case here, you can see that the current subset is going to be an empty array here. So basically we want some sort of way to add to the current subset. And of course, I isn't going to initially be equal to the number, the length of nums. So we're going to have some recursive calls, and then the base case will eventually push the current subset to the subsets array. So what we want to do is we want to include the current element in the subset. So basically you have an array of numbers, and then let's say you're on the first number. We just take the current subset and then we just push a number there. So for the first case, we're just pushing the first number here. And then what we want to do is we actually want to recursively call this backtrack function here. And we just add 1 to it. So we can just say I plus 1 here. So that'll go to the next element in the array, and it will add that to the current subset. So current subset's sort of defined up here. So, you know, if you have a 1, 2, 3, it's going to take 1, then 1 and 2, then 1, 2, and 3. And then eventually, let's say it gets to the end and 3 is the last one, then eventually it will just push all those to the array there. So they'll push 1, 2, 3. But you might, after you push 1, 2, and 3, you still need to push 1, 2, and 1, and some other combinations there. So what we can do is we can actually exclude the current element from the subset. So once it makes it past that first recursive call, which goes through and loops through the numbers, since we've looped through the numbers, if we sort of pop 1 off the end there, they'll get the numbers combinations of that aren't the last one, so the various ones that you've looped through for that particular iteration. So basically, if we want to exclude the current element from the subset, we can just take the current subset and then we can just pop, and that's perfectly fine to do because we've already pushed it to the current subset before we've recursively called it. So when we get to the last one, we can just pop it off, and then they'll take us to the second last one, let's say. And then we can call backtrack for I plus 1 again. So it looks like it's doing a similar thing, but it's just doing it for the ones before it. So the first time I saw this, I thought this was a little confusing because you know, when you're doing recursive calls, if there's more than one recursive call happening, I like to sort of think my way through it. So this is the solution, and that's perfectly fine. But I do want to just sort of track through this just to prove this is the case. And this is really good, especially when you're getting started with recursive problems or more complicated recursive problems, or if you're just having a hard time understanding the solution. I think a good way to do this is to just sort of log out the call stack. So basically, let's just sort of go through this here. And we're in particular going through this backtrack function here. So we can see that we've passed in 0 here. And then when we call backtrack, we have a I plus 1 here. So basically, if I is going to be 0, we're going to say that the current subset is going to be equal to, and I'll say CS for current subset is going to be 1, because the current subset, we've pushed the first number there. That's going to be, let's say 1. Let's just say we're using the numbers 1, 2, 3, or the same as the example. So 1, 2, and 3, 2 to the power of 3 is 8. So basically the current subset is going to have 1 there. And then basically we can see that the current subset's here. And then we've got to line 12 here. And then that's sort of pushed to the stack, the next backtrack. So that's going to be backtrack I is 1. So that's going to be I is 1. And I might just make a note here to say that essentially line, so this is line 13 here. So once we finish the nested recursive calls, it will go back to line 13, and then it'll do the next lines here. So I would say line 13, but as I'm going to add more and more lines and comments, it's not going to be line 13. So I'm just going to say line before pop. And that'll just be a reminder to return here and do the rest of the walkthrough. So now we're on the next iteration, or the next recursive call. So I is going to be equal to 1. Now the current subset was already 1. So we can just go ahead and add 1 plus 1, which is going to be 2 there. And then once again, we're going to take the line before the pop here, because we're going to call another where I is equal to 2. And when I equals to 2, the current subset will be 1, 2, 3. And then once again, we're going to want to go back to the line before the pop. And then finally, we get to I equals 3, which is the base case here. And if we look at I, when that's 3, we can see that, well, that's going to equal to the length of the numbers array. So we go ahead and we push the current subset. So I'm going to put S here for the current subset, which is an array of arrays. So we push that current subset to the subset. So we have something like this. And that's going to be the end of that. So I'm just going to put fin here for finish. So recall, now we need to go back to finishing off these lines here for the previous calls in the call stack. So when I equals 2, for example, basically if we then pop the the current stack, or the current subset I should say, would end up getting the new current subset, which would be 1 and 2. And then we call the next back track function. But since I equals 2, and then if we substitute 3 in there, that will take us back to the base case. And then we can go ahead and we can just add this here. So that will be the 1 and the 2 here. And then this will be finished here. And then we just do the same thing again. So here we just pop that value off here. So basically what we can do is we can just say, well, if we, well, this one's a little bit different because when we call this, it won't necessarily be the last thing there. So what we can do is we can actually just, let's just say up here, I'm just going to call this X, let's say. What we can say is X So when I is equal to 2 here, or I equals to 2, we can say that, well, if I is equal to 2, then the current subset, if we, what is this? So we've got the current subset 1, 2 here, and then we pop the 2 off. Then we can, since we're on 2 here, if we add the 1 plus 1, or the 2 plus 1, that'll be 3. So the current subset will be 1, 3 here. And then we can, of course, add that. And then that will be the end of that here. So then we need to come back to our current subset. So we got 1, 3. If we pop something off that, basically would have something like this here. Well, x, I don't know if it's x or not now, but when I is 1, we pop the 3 off, and then we'll end up getting just 1 there. So we can just add the 1 there like that. And then basically you just sort of repeat that workflow. And then if you do that again, basically, so we did it for this line here. If we were to do it again for this one, instead of having 2 here, we'd have 3 there, where I is equal to 2, 1, and then 0. So you would end up getting something, and I don't need to go through all that again because that explanation would cover that. So I'll leave this as an exercise to the viewer. It's already quite the exercise just to go through this anyway, but this is just something that helps me mentally go through it. And then once you get to the very end, you'll just get to the empty subset there. So hopefully that was helpful, but I'm just going to delete that now. And then I'm going to submit this code here. So one thing I'll need to add here is I'll actually need to add a return statement here. So let me just go ahead and add that, and then I'll submit the code again. Because the return will exit out of the backtracking and then won't do the rest because you've already made it to the end of the current subset. And we can see that this actually beats 90%, so that's pretty good.